I recorded this after I recorded what you're about to watch, just as a little disclaimer. If you are not familiar with networking and how like how Wi-Fi works and how all of this stuff works, this video is going to be pretty technical. And so once I'm done talking about HTTP and how it basically handles server client and stuff, once you hear the word TCP, you can stop watching this video if you're not too familiar with all of that, because I just kind of go down this rabbit hole of network connections. However, if you're interested in how like video games communicate and how streaming works and stuff like that, continue watching. It's all good information. It's just it can be a little technical for those beginners who are still trying to get into like what networking is. The important part is when I talk about HTTP requests. So now we're going to be looking at HTTP requests. Basically, this is how the browser is able to communicate with clients. So there are several layers to networking, and you can look up layers of networking and look at these images, and you can see what's going on here. All of them are the same thing. Some of them are kind of crazy graphics with this Ethernet cable that is going everywhere. Like you can see what's happening. But basically, to summarize what this is saying is HTTP is how a client. It's the concept of client and server. So a server is a computer somewhere else that a client is communicating with. Okay, that summarizes all of the internet. The entire internet works that way. Okay, if you are accessing a web page, you are accessing files and data on a separate computer somewhere else in the world. When people say the cloud, it's just another hard drive, another computer somewhere in the world. Okay, so the way it communicates is over HTTP generally. Okay, so you have this HTTP, which the way it works is through request. You have this request, which goes to the server, and the server sends a response back. SREQ. Okay, so the client sends a request to the server, and the server responds with some sort of whatever. It doesn't matter. Okay, it can be anything. Okay, so that is the fundamental thing of HTTP. So this then talks about like what is TCP. So this gets into I recently learned about TCP versus UDP. Basically, if you have two computers plugged into an Ethernet switch, so this is a computer, this is a computer, and this is a switch. And they're communicating with each other. They're communicating generally. HTTP runs on TCP. So basically, this computer, say this is the server, and this is the client. This is the server, and that's a client. All right, server, client. This computer sends a packet over here saying, "Hey, can I connect to you?" And the server goes, "Yeah, sure, I'll connect to you." Just acknowledging, saying that, yes, I will connect to you. And then the client goes, all right, great. I have recognized that you are now connected to me. Cool. So now there is a connection between these two computers running over an Ethernet cable. Okay. And you don't even need a switch technically, but you could just have an Ethernet cable running between the two. Okay. This is just basically network transport protocol. And then the HTTP runs over that TCP connection. So this connection that I just described, where you have that acknowledgement thing, HTTP wraps around that. HTTP, and uses that TCP protocol to communicate with the server. Okay, so basically TCP, it sends a packet, or it can send a bunch of packets. The server then has to figure out which packets are, like, which order the packets go in, and if it didn't receive a specific packet, it'll say, hey, I didn't receive this packet, and the client contains duplicates of those packets. And so if there is a failure, it'll send the packet again. And if the server receives 2 of the same packet, it'll just get rid of 1. Okay, so the idea of TCP is it is a connection base, and it is incredibly stable because there should be no packet loss if all is working properly. Okay, so HTTP, in order for it to communicate with another server or to another computer, it sends, hey, I want this information. It's running over a TCP protocol, so you know that there is going to be 0 packet loss. Or in an ideal world, there's going to be 0 packet loss. There's another one called UDP, which is very similar. However, there's none of this protocol that it says, hey, can I connect to you? And then it sends back, and then it sends back. And there's none of this like duplicate packets over here, and then this server handles the duplicate packets. UDP, all it really is you have your server, or you have your client, you have your server, and the client, actually I wouldn't even consider it client and server. I'll just say computer and computer, okay? And the computer is just going to send packets over. Rapid fire. Here's a bunch of packets. Deal with it. I don't really care. It doesn't matter, right? And so this is ideal for like video games where you want low latency. So a lot of video games run over UDP because once the state has changed, you don't really care about the previous states. So you just care about the current state. And so the order doesn't really matter as long as it's generally in the same order. TCP is high latency, UDP is low latency, but is technically unstable because there's none of this connection and then duplicate packet information, that kind of thing. So HTTP runs on TCP, HTTP. However, UDP is useful for like streaming videos, video gaming, streaming audio, etc. UDP is generally used for those kind of things because once that, so say you're running through a stream, once the like frame is over, you don't care about it, so you just move on to the next one. And generally, UDP is going to be in the same order, but TCP ensures that it was always in the same order, and so you can send more complicated data like HTTP. So, all of that was really complicated. And then it gets into HTTPS, which is basically a secure version of HTTP. From what I understand, and correct me if I'm wrong. So you have your server, you have your client and your server, okay? And then you have this third-party system that handles certificates, cert, okay? And this server contains your files that you want to send to your client. But you want to make sure that there's no person in the middle here that is handling or that is sending you fake data, okay? There's no, like, hacker, okay? So there's no one acting like Google, say the server is Google. There's no one acting like Google so they can steal your information. This is what's called a man-in-the-middle attack, okay? So HTTPS, all it does is the server requests a certificate from the certifier, and the certifier gives it a certificate, and so it can send encrypted information and basically bypass this. And so, God, let's just make sure I'm saying this correctly. This computer, basically, it encrypts information between here and here so that you know, between the server and the client, so that you know that the client is always communicating with only the server. If something is running over HTTP, you don't know that for certain. So you could be working with a separate thing. And let's just double check. How does HTTPS work? Based on the transmission of, okay, let's use a graphic. Image. Graphic. Okay. So if I go to Amazon, it's going to go to a DNS server, basically a one-to-one relationship between the domain name, which is the Amazon.com, and an IP address, and we'll send to this IP address. And then the HTTP, it'll do what's called a handshake. Oh wait, no, that's already happened. That's the TCP thing that I was talking about earlier. And then it'll do the certificate. Make sure that the certificate that the server is sending is truly working with Amazon.com, for example, right? And if it is, then you know that the data that you're receiving is encrypted and is not some sort of man-in-the-middle attack. Okay, so it's kind of complicated, but basically HTTPS prevents man-in-the-middle attacks. Okay, so you can read more about HTTPS here and understand how it works. And we went through network layers. It gets kind of complicated, and I know that a lot of this may have like brushed over your head if you're brand new to networks, but this concept is actually quite important. So I just want to make sure that you know how this works. So that's basics of HTTP requests and how it works and stuff. Okay.